Hello, everyone. A very warm welcome to all. I am Pallavi Nanda, your host for this pronounced session. I'm extremely privileged and excited to have been given this opportunity to be a part of our very own sapient Chance's BeConnected Virtual Conference 2023. We have participants joining today from locations all over the world. And before we get started, I would like to take a moment to share our appreciation for everyone lining up their schedules across the time zones in this way. We are elated to have Mr. Josh Wiseman as our guest speaker for today's insightful session on the double trust problem of AI in operational use cases. Josh, a native of Atlanta, holding a degree in computer science, operations research, and financial engineering from Princeton University, has worked alongside industry and technology experts to enable operational data use cases for Fortune 500 companies and government institutions. The speaker will draw on his experience and also explore various tools to effectively engage on the ground operators and business owners with machine learning and artificial intelligence as emerging technologies. We'll be conducting a short Q&A at the end of this session. You may send in your questions at any time during the presentation in the Q&A window below, and we will collect these and address them at the end of the presentation. Also, if you experience any technical issues during the session, please return to the virtual lobby where we have our tech assistants from the conference hosting platform to help you out. It's time to hand this over to Josh and get the virtual presentation started. All yours, Josh.
Thank you so much, Pallavi. Thanks for the time, and everyone else is joining in. Really appreciate the opportunity. I'm super excited to talk to you about this problem, this use case that I'm describing, the double trust problem of AI in operational use cases. We'll get into what that means. But just a brief note about who I am. Thank you so much for the very warm introduction. Again, I'm Josh from Atlanta, Georgia. Got a degree in computer science and operations research from Princeton. Worked for a few years at a company called Palantir. Some of you may know, in the data integration space, data analytics space, and we'll draw on some of those experiences in this presentation. Currently, I actually live in Israel. I work as a product manager in a software company that focuses on logistics optimization software for small and medium businesses who sell online. So we're really excited for the opportunity. I'll jump right in, and excited for the Q&A at the end as well. So where do we start from here? So where we start is the topic at hand, right? The topic at hand is the decades-old hype around machine learning and AI, right? Operations and major corporations, right? Think of the biggest companies in the world, have been living with hype around the promise of ML and AI for decades. Cost savings, process automation, AI sidekicks. There's been a lot of hype around this topic for a long period of time. And so the talk will review two basic requirements for rolling out those use cases in machine learning and artificial intelligence. And we'll talk about sort of AI, what that means, what we mean it, and how we mean when we talk about it. The two basic requirements for rolling those out. Namely, one, a trusted and interconnected data ontology, maybe a data model, and two, a transparent decision-making making framework. Those two requirements we'll get into throughout the call. We'll also explore the North Star in ML and AI work, and discuss various tools to make these emerging technologies an operational success as opposed to just a cool technology that's a nice to have around the industry. So that being said, where do we start? The way we'll actually talk about these things is a bit about the use cases today in AI. We'll talk about what AI is aiming for in the short term. We'll talk a little bit also about how to bring operations into that. How do we bring the world of operations from the biggest corporations in the world into this AI conversation, as opposed to just being a chatbot? Some anecdotes from some experiences I've had and what that might inform us about the topic at hand. And then in a tactful way, right, thinking about asking the right questions to get there. What do we need to do to both in a technical and a non-technical way, get towards some of these outcomes that we're aiming for? So what is AI today? The state of AI and AI use cases today. For most people, generative language models and generative image websites are, quote, AI, right? You look here at this picture. This is a picture of ChatGPT, and this is what AI means to them. It's a chatbot. You can ask questions, you get back information. But, if I asked you define, quote, AI, define artificial intelligence, this wouldn't come as a surprise to you that it's pretty hard to do right now. In the past, we'd call, we've had these technologies like machine learning. In the future, we hope to at some point get to something like artificial general intelligence that models really what humans can do, make decisions autonomously, have insight on things. And this sort of AI now in the middle is a bit of a rebrand of what machine learning was, with some cool new technology that's been maybe revolutionary technology that's been developed on the generative text and language model side. And that's what we're looking at right now. That's this picture of ChatGPT. So machine learning is still around, right? So the old world of machine learning that we used to call kind of the advanced technologies of the time, machine learning is still around. Predictions, pattern matching, online learning, continuous optimization, all these things are still around. And use cases operationally like predictive maintenance, recommended ads, clickbait, facial recognition, fraud detection, tons and tons of use cases in the machine learning world that are still around, but it's been rebranded now as artificial intelligence, especially when we include now the topic of generative text, language models that we can interact with. So having these communicate with each other, these sort of rebrand, it's important for us to again think about and remind ourselves what the objective is in all of this, right? So historically, we had this objective, or maybe a fear for some people, of getting towards general artificial intelligence at some point in the future, and that would be something that made in the craziest world would completely make useless the point of having human jobs, and instead artificial intelligence could do everything. And in the short term, is really just a fear-mongering thing to worry us about the prospects of AI. But conceptually, there was machine learning and neural nets, which played a role and are very similar in other optimization models that led to this new technology today, which is kind of a rebrand again of those things, plus some additional generative text models, which are extremely powerful. And moving towards, in the future, towards something like a general artificial intelligence. Again, I'm only doing this just to talk about sort of where we stand today. And I don't want to confuse terms, right? I want to be on the same page. The goal of this conversation is not to define AI, or not to define how we get to AI in the future. The goal of this is to talk about how do we get to something useful. How do we get to something where, quote, AI, whatever it is involved and embedded in real operational use cases with people on the ground, executives, analysts, operators, wherever they are in big companies doing operational things. We want AI to be embedded, the technology to be embedded into those operational decisions. And the question is, how do we get there? And we'll talk about that throughout the course of this discussion. So some real world examples today. Like I mentioned, many of the quote AI use cases today are centered around ChatGPT and generative texts or generative images. So in these three examples, you see one, for example, is LinkedIn on the bottom right, where you provide some sort of text, and LinkedIn takes that text and outputs what they think would be a more appropriate or palatable version of that, or spiced up version of that to put onto their website, and get have a higher likelihood of getting response and views and feedback from other people. That's one example where you give an input, you get back a response, a generative text. An example at the top, Gmail. This is something people may have taken for granted for a while. Recommended text. Gmail takes as input your entire corpus of emails that you've been providing to them. It knows a little bit about your personality, how you might type, the types of things you might say or respond to, and as well as the specific email that you're writing, and will provide specific text as a response or as a prediction for what you might want to use to fill out the email or fill out the sentence. Again, generative text. And on the bottom left, we see a company called Loom providing something that's slightly more advanced in a way, different, has more to it, where it takes a video, converts the video into a transcript, right? So that's sort of one model on top, convert the audio into a transcript of text, then take that text and provide a summary of the text. You see on the bottom right of that picture, there's a summary. And then on the left-hand side, you see two tasks that were created for your viewers. Basically, it's distilling the text that it's created into specific tasks that it's asking or that you've then recommended people perform, right? So it's not only producing a summary or a similar text to the one you input, spiced up or whatever it is. It's also making a degree of a prediction, but in a more advanced way, a specific task as a result. And think about the amount of complexity that might be involved in doing that. There's machine learning models behind the scenes. There's neural networks, tons and tons of parameters that are being used to generate all of this and produce all of this input text. And it's really great. All of this is excellent. But again, this is, if you think about it from an operational standpoint, it's sort of a recommendation. It's a generative text filler, but we haven't gotten into the use cases that really represent the meat of a business. These are just helpers. Around the business, this might be like a sidekick, an assistant. That's sort of the link. That's sort of where we are right now with the technology. And I just want to show you, for those who love the dystopian version of artificial intelligence, here's a picture from the movie Eagle Eye of what AI has the promise to do. Basically, know everything, do everything, take over the world. Again, we're not really aiming for that in this conversation, and I hope we don't get there in general. But what we're aiming for is something more operational and more in our control. So what are those things that we are aiming for? What are the pieces of the puzzle that we want, quote, AI to be able to do and perform? So I'm going to name 5 different things that we want AI to do. The first thing, and they're going to be all related and in sequence. So the first thing we want AI to be able to do, and this is something that the LLMs, that the language models today have been doing, is understanding and articulation. It has to be able to be something that we can communicate with in a human way. This doesn't take into account how good the language is or how good the information is that's coming out. It takes into account the ability to communicate with that thing using words, using ways that we can reasonably understand. In addition to that, though, the types of things, the understanding of the world that the AI, that this new technology is speaking about, have to be realistic and make a good case that it understands the way the world works, right? So there are chairs, there are bookshelves, there's floors. Chairs lay on the floor, they don't fly in the sky. That's an example of the knowledge graph, right? The way in which the world is conceived has to be well understood by the language model. And take it a step further, if you were a business, then it also has to understand the way in which the business operates, different from another business. And so this is something that we'll spend a lot of time talking about. The knowledge graph of the business, in addition to the knowledge graph generally of the way the world works. Ranking and decision making. So once you can communicate and once you can understand the world, you also need to be able to rank for decision making, rank options, preferences. This is typically where machine learning has come in the past, be able to provide specific recommendations, top of the list, top 5 recommendations, those kinds of things, preferences, in order to help us then actually take the action, which is the result of the ranking and the prioritization. So if you were a human and you would be judged at a business on your ability to understand the way the business works, to rank different preferences when issues came up, rank different operational options for you to take action, and then actually take the action of the most likely or the best option that was from the preference or the lists that had been ranked previously. Once you take an action, you actually have to be able to continue your learning, understand how that action impacts the world. And all of this is crucial because it suggests that the way in which people operate and the way in which we hope operational AI will get to contributes to a very specific set of tasks that need to be accomplished. We need to be able to communicate with the thing. It has to be able to understand the world, understand the business. It has to be able to make recommendations that are realistic and reasonable based on the business in a way that's understandable to the business. It has to be able to actually take an action, literally perform an action inside of a system in a dynamic and digital way. It has to be given the control and power to take that action. And then once the action has been performed, it needs to be able to learn how that action has impacted the world and respond accordingly. And so all of these types of things are contributors to a true operational AI use case. Again, forgetting the dystopian version, a more operational version that someone could get along with would require these different components. And we are only somewhat, somewhere along the first 3, and separately, the capabilities are there for 3 and 4, and then maybe 5 is something that needs to be discussed and has not been very well understood so far. So just want to provide a small context on what this would represent in language that maybe technical folks understand. Understanding and articulation, that's sort of the natural language processing technology that's been developed, whether it's LLMs or it's other NLP use cases. Knowledge graph is typically defined in some sort of ontology or data model. The ranking and decision making, that actually is the machine learning, the neural nets, the optimizers that we've been building separate, right? So for the businesses now that are using these types of things, that is, that fills a very specific function. It helps us make decisions by ranking different options. And that's going to be crucial when we think about bridging the gap between LLMs and these language models and operations in the field. Furthermore, when you take action, you can be programmatic, for example, through APIs. and continue learning. If you were going to continue learning in an appropriate way, it would take into account an actual feedback loop, a digital one, as well as a social perception feedback loop that takes into account how people emotionally receive and respond to the actions that have been performed, right? So we want sympathy, empathy, and understanding of the impact on people's lives as a result of the decisions that we make. If anything's going to be autonomous, or at the very least, we need to track the response there and the continued learning. Okay, so these are the 5 major pieces that we're going to take for granted contribute to an operational AI use case, and this is what we need to get to. However, this also sets up the double trust problem. Like, where on this loop have we failed, or is it a technological problem, or is it a conceptual problem, or some other sort of problem? Where have we failed to actually getting to operational AI? Right? When you think about how executives in today's day and age actually think about AI, quote AI, in today's day and age, it's full of distrust. And that's maybe it's intentionally because the industry is, quote, young, or maybe there's something in the way we've built out the process that has lacked trust from different stakeholders. Here's 2 Wall Street Journal articles, the headlines from them. And the first one says hallucination, artificial intelligence. And the second one says companies want workers to trust AI, but not completely. Hallucinations are when chatbots sound, let's say ChatGPT sounds completely confident in what it's telling you, but it is completely wrong. And that type of lack of confidence, that total hallucination, happens all the time, and it's something that people watch out for. How does that possible, right? So you have complete articulation. It's chatting like a human would chat. It's talking like a human would talk. It's typing like a human would type. But the content, the knowledge of the world is totally wrong, right? And that gap speaks extremely strongly to a serious gap between how the world is represented and how the world is then caught in real life versus codified in code that an LLM or a language model can actually understand and take and make useful. And the second one is that when companies see their employees making use of AI, whether it's a chatbot or who knows what it is, maybe it's an ML model, the companies want workers to trust AI, but not completely. Right? They're seeing lots of situations where workers are overly trusting, and they want to avoid that. And what it represents to us is that the decisions that are being made by, or the recommendations that are coming out of these AI tools are not strong enough to be relied on their own. And that is a gap we eventually would like to minimize. I'm not saying that AI would be, or these technologies would be completely used on their own. Maybe in many use cases there would, and then in some use cases they wouldn't. But we want to get closer towards operational decision-making being made by things that don't require human input, as long as the information is there. So this points again to the double trust problem, which I'll frame as follows. The first one is that there's not enough trust in the knowledge graph or the ontology. The AI interpretation skills, the way it interprets the world, it needs to understand the world, but it needs to understand a business. It needs to understand the foundations of the business, the way in which different entities in the business interact, the way in which machine learning modeling interacts with different components, right? What is revenue with this business? What is a customer in this business? What represents a failure or a maintenance issue? All of these types of things need to be clearly understood and trusted across all levels. And if they're not trusted in a data model, then they're certainly not going to be useful when making decisions on top of in a language model. The second issue that comes up is decision-making and the ability to act. So if we lack trust in the executives lack trust in the knowledge graph itself, but they also lack trust in the way decisions are being performed or being recommended vis-a-vis these things. So the trust in the decision-making and the ability to act is itself a very significant problem. People already distrust the decision-making process, and that leads them to add human in the loop, which in a way helps and in a way hurts the process. There's growing recognition that AI tools require human oversight, and there's been leading companies increasingly recognize that these technologies are most effective when they are complemented by humans instead of replacing them, which is all great. Like, that should be our objective. We don't want to replace humans, but what I think we should be doing is having AI start to automate. Again, this is not new, automate things that can be automated, and then put humans on more complex tasks and advance the business, right? We don't have to have fear of people being kicked out of their jobs. Instead, we could advance the jobs that those people are doing, advance the business, and then the technology takes over on the more basic functions. And so a lack of confidence and a lack of trust in the ability of a tool to actually make decisions or recommend the right decisions is a crucial piece in our rollout of AI to operational use cases. I want to give you an example of what I mean by that. Here's a question I asked ChatGPT, and I know this is it's not a great example, it's not perfect because we haven't done some of the steps prior to this are not completely clear, but it'll give you a sense of what I'm trying to get at. Here's a question I asked: what is the impact to my business on predicted revenue if I decide to shut down my New York factory for maintenance next month? So next month, I'm considering shutting down the factory for maintenance, and I want to know what the impact might be on predicted revenue. And so the response from ChatGPT is, well, predicting the impact of shutting down your New York factory for maintenance on your business's revenue requires a comprehensive analysis of various factors, data specific to your business. Here are some key considerations to help you assess the potential impact. First of all, it gives a list. It gives me a list of things to consider, but it obviously doesn't have access to my business's specific data, and it doesn't have any specific way to calculate the analyses and the specific functions that it's recommending. And then furthermore, what it responds at the end is to say, well, to get a more accurate prediction, you may want to create a detailed financial model that considers these factors, including revenue loss, cost of maintenance, and any potential mitigating actions, right? So all of this stuff is pointing to the fact that these decisions or this recommendation engine is not going to be housed within ChatGPT, likely, at least not for many, many years. Instead, what it's already telling me, it's already predicting, whoever's the feedback that ChatGPT is getting is that these decisions are actually models somewhere else that need to be incorporated into ChatGPT as well as live business data. And once we have the live business data incorporated into ChatGPT and we have a model incorporated into it, then ChatGPT would be able to then call the model, call the entities relevant, and run it and give me back a result. But it doesn't have knowledge of the business, it doesn't have knowledge of the business data, and it doesn't have knowledge of the way the models in my business are set up to make a recommendation. And as a result of that, the operational use of ChatGPT is completely moot, or at least in this context, I can't get any sort of answer. I can only get a recommendation from some sort of analyst outside the scope. So what I want to do is walk through an example, one example that might provide a personal, real example that demonstrates how hard it is to get these pieces correct. So for my time at Palantir, we were tasked at providing software to help answer the following question. U.S. government agencies needed to distribute PPE, personal protective equipment, and vaccines according to the biggest current and predictive needs. And they asked us, how do we get to an answer on that question? They want to distribute PPE and vaccines according to the biggest current and predictive need. So I want to tell you a few pieces about what made it challenging and what the bar for good work would be today if we were asked the same question again. So major organizations, they want to work together, many different organizations, they want to work together, but they don't have a shared workspace that had trusted, updated data and where they could perform analyses with all of the modeling capabilities they were used to in their siloed worlds. So some CDC folks did this, White House folks did that, HHS folks did this. Again, this is US government stuff. All of these organizations did totally separate things, all totally valid, but then now they're making cross-organizational decisions and the data model wasn't there, or the workspace wasn't there to do that. So the urgency is extremely clear because people are dying at a very, very, very fast pace and new real use cases are coming up every few hours. Someone will message us, say, we need this, we need this, we need this, we want to make this decision, we want updated data for this decision, but all of these use cases are extremely urgent. And what they needed was a data integration tool more than anything. They needed a unified data model more than anything else just to get started, to get a picture of the real world. But even before they could do that, even once they had that, only then could they start thinking about the decisions they had to make on top of that data model. So in situations like this, high-ranking government officials, what they needed was knowledge. And knowledge is not a new insight, it's an old insight. Knowledge is power, but the problem still exists. They didn't have it. And even in 2020, organizations like Janesys and Palantir, many organizations know that this is a rampant issue. Data integration is extremely, extremely hard. And most organizations can't get it right, even in a way that's trusted, at any levels of the organization. So, for example, the agencies that we were speaking to, they needed to connect existing data pipelines with manual pipelines. They had forms from hospitals and they had manual entry from analysts on the ground. Plus, they had PDFs that they needed to scrape and they had websites they needed to scrape and they had their own data pipelines, which were more robust, but it had been in siloed organizations that hadn't been unified. And once we had all the data kind of just flowing in the same direction, then there was a rigorous vetting process for the data itself, and the data analysis, maybe even on a county by county level to get the COVID counts, on a county by county level, and the correct number of ICU beds on a county by county or state by state level. All of that stuff has a very rigorous data analysis process and data validation process. So there are many different components that made this problem exceptionally hard. All of the things I mentioned, the data side, plus security across different organizations, no code environments for the people who needed to analyze but didn't know how to code. On top of that, they need, ranking models. Each organization maybe has a different conception about how to build a machine learning model to define the predicted need of a state or a county or whatever it is for PPE and vaccines. And most importantly, you have to get it right. You have to get this data model right first, because if you get it wrong, all of the downstream use cases that you're getting every few hours, you're going to have to keep revisiting the data model, right? And it needs to be done right. It needs to be done in a comprehensive way. And it had not been done before. And you see, when you think about the actual data model that had been incorporated, it's extremely large, right? From vaccines to hospitals to beds to equipment to states, counties. Again, this picture of the United States with per county COVID counts and different agencies. The data model is an extremely important part of getting this right. And only once you have the data collected across all the organizations, then you can start asking more complex questions, right? So the ontology in the data model, and this is a crucial point I want to make, ontology and the data model across the organizations is extremely complex, but only once you get the data model in place and you vet it and people appreciate the data, they say it's up to date, only then will you get the buy-in from business owners to get to operational use cases, right? Organizations are not going to trust you to start bringing data into operations if the data is not completely accurate. And that process is still way too hard, and it needs to be better. So, at every level, the very simple operational question depends on the ontology being representative of the real world. So, when we think about the questions that we had, the question that we had been phrased, U.S. government agencies need to distribute PPE and vaccines according to the biggest current and predicted need. That basically models or mimics three extremely specific functions that we needed to account for: unified data model, a vetted data pipeline, targeted machine learning models. All these things had to be in the same system that could be used. On top of that, you needed software to chain it all together. And on top of that, if we were going to be asked the same question today, then we'd need some sort of chatbot to help us assess, ask questions vis-a-vis the data model. We need to be able to actually perform actions on top of that to help us make decisions. So, if we were posed the question of how close we were at the time to operational AI and the way we think about it today, we were close, but not so close, right? So there was no intelligence, there was no language model, no articulate sort of chatbot we could communicate with. These types of things were still a few years off. And at the time, the thing we were completely focused on was the data model. It took so long to get the data model right just to get to operational use cases. There was, much of the time was focused on that. And so that's a clear area where we actually need to focus on as organizations to get to real operational use cases. You can't get there unless you have the data in place. So what I want to focus on is, just in brief, why was it that some of the data model was, why hadn't it been focused on? Whether it's at government agencies, we saw this consistently across U.S. companies. Why was it that major organizations had tons and tons of data and they had their own data lakes? But why was it that it's not being accurately used in operational use cases? It's just sort of being like, it's feeding information to these data lakes for then some sort of analysis offhandedly, but it's not like embedded in solving a real world problem and making predictions for organizations in a live way. And I think the reason is that historically CIO and CTO teams at large organizations never focused on having enough data hygiene and data management with respect to operational decisions. Instead, they would focus on analytics or having a data model there for, very specific use cases in, just updating the data lake, but it needs to be, operational decision makers need to be looking at this thing and say, okay, there is something that is extremely useful about the way this data is set up vis-a-vis the specific business problems that I need to solve. And those were not being met appropriately. And, I just want to point at all the different things that that came up throughout the process of this, these learnings about why data integration still lags at the highest level. Look at all of the things you have to be able to support, whether it's data transfer, updates. You need to be able to support streaming, live updates, data security models across different organizations, health checks. You need to be able to have operators of all levels be able to vet the code in non-code environments. The real world ontology has to be completely vetted. Bidirectional data movement, reading data, writing it back to the system. Tons and tons and tons of reasons why data integrations today are still not vastly trusted by all levels of their organization. And it's a major reason why operational use cases are still not rolled out in the way they should be or could be. Okay, so that's just one anecdote though, but the question that it leads us to is, well, if, is a better data model going to solve our problems of getting, then can we deploy AI? What if we had a better data model? Would operational use cases of AI be more relevant? Well, probably not. We still need to build trust in the decision-making of AI itself. And I'm going to give 3 examples of types of questions that even if you had a really good data model would still not be answerable by today's day and age by the types of chatbots we have today. And it's something that's not being asked yet and should be asked more across the industry. So the first one, right? So where are we headed? Let me paint a couple of examples of the types of questions we should be asking in the near term. And we should aim to improve our sort of AI technologies to be able to answer these types of questions more effectively. And only once we get the data model and the actual machine learning models, et cetera, in place, you will see that those are requirements for answering these types of questions. So for example, here's a transportation company. An executive hears about a hurricane, let's say in the Gulf of Mexico, and asks, or a typhoon, and asks which fleets are at risk, which ships are at risk, and what is the risk to my revenue and the maintenance of shutting down those fleets during the hurricane, right? So a person is making a trade-off between leaving ships at risk in the ocean and shutting them down, and wants to know what is what is at risk, how much money would I lose, and what does it mean to be at risk in general? That is the type of question we need to start building answers to in a programmatic way. Another example, an energy company. And you see these examples are not taking action yet. This is still just recommendations, right? It's not like we want an AI bot running and doing these things on its own, but we want it to give realistic answers to those questions over time. So an operator asks what region has the highest probability of containing oil based on the last 4 weeks of exploration and tests. Again, a recommendation that understands the data world at the organization and understands the way to define a high probability, probably a model, a high probability of containing oil. Just a final example for those in finance, an asset manager asks what asset classes are risky and deserve attention in the upcoming 3 months. If you understand what's behind this question, it's knowledge about the organization's financial structure and how the data is laid out across these different organizations, across the organization, and has models built into it to understand what risky means and what deserving attention means. So these are 3 examples that in every industry, the first step towards operational AI is not actually having the AI take action, but to have business-aware, ontology-aware responses. If it doesn't have those types of things, we're going to be caught in a world where AI is totally stuck in the chatbot realm and doesn't bring itself towards the operations of a business, the meat of a business, to actually answer questions that have the ability to move the needle, right? Things that matter in a sense of urgency. Those types of things, if you want the AI to get there, the technology to get there, you need to start asking operational questions through an operational lens. So that being said, you see that through some of these questions that the way to get some of these answers is by linking a data model with a language model, right? LLMs, ChatGPT has knowledge of your business's ontology. And then in the middle, there's something about machine learning models that are built by various teams that link all of these things together. And so what I want to do now is provide some real world recommendations that I see as being relevant to actually getting there. So let's start with brownfield territory, areas that data software companies should know really well and have been working on for a really long time. So for example, in the data model space, embedding data teams with business teams. They shouldn't be working separately. These teams, business teams should actually have not just a separate analyst resource, but they should be working together on solving real world problems in the same environment. That's one thing. The data models, if you do that, you will see that the data model starts to represent the real world use case. Another thing, rigorous data validation until cross-team alignment. If you don't have cross-team alignment, the data model becomes useless in an operational sense. It needs to be extremely well vetted, and only because of world-class process in data validation will you get to a result that business owners trust. On the data pipeline side, right? So you're just coding, you're coding the business vis-a-vis, you're writing all these integrations to get them, to get data from one point to another to look a little cleaner, filters, et cetera. You also need to embed business logic, right? So if you have an entity called company or an entity called customer, there should be analytics on the same data table that represent the customer analytics, the number of times they've done X, the percentage increase in value Y. Those business analytics should be encoded in the same data pipeline in order to get into the data ontology. And you'll find once you start embedding with business teams that non-technical users have many more questions that you took for granted, right? So once you give the tools to non-business owners, you give them the tools to analyze in ways that make sense, and you give them keys to the data model just to understand it and communicate with it, they will start asking millions and millions of questions that start opening new use cases to push the needle in big companies. So that's the brownfield side, things that make sense to people in the data in the software space of data integrations. But on the greenfield territory side, things that have a lot of current new R&D efforts that are going to help us bridge the gap of the double trust problem, bridge the gap of a lack of trust in the data model and a lack of trust in the decision making. Well, there's a wide open space right now to connect the data model and the ontology to the language models that we're currently interacting with through text. And in that, there's a massive security problem for leaked data. That's something that really needs to be focused on. Major companies are now working on this space. In addition to that, being able to just literally just connect the LLM to the data lake, to the data model is an open problem that many people are working on. In addition to that, right, you have decisions and actions, and you have signal and feedback, and all of these are spaces that have not yet really been well understood, right? So it's the scary part of the AI when it can actually take the action. And the way we should go about doing that to build trust in the industry is to establish proper processes for taking action and for and proper protocols for having humans in the loop and those types of things. And once you have the processes in place that help prevent poor decision making, then you'll start to see an increase in the usage of these things in operational capacities. Similar on the signal and feedback side, you need to have the feedback to ensure that the signal is understood and received and is and whatnot. So all this being said, we have the data model side, we have the decision making side, but what will help us bridge the gap? So models, machine learning models, neural network models, optimization models are the perfect bridge to then gain the trust in the ontology-aware LLMs with the distrusted decision-making skills. So how do you make the decision-making more trusted across organizations in these chatbot world? Once you've already then connected it with a ontology-aware LLM, well, machine learning models are a perfect example. We've been building machine learning models for a very, very, very long time. They're kind of like outsourced decision makers in a way. If ChatGPT knew what machine learning model to call, it would be a much more effective tool as long as it knew the ontology that we were dealing with. And we saw this actually from ChatGPT itself at the very beginning. Once ChatGPT knows what models represent what parts of the business, it actually become an extremely strong user of the models that we've built separately, which in the past had been totally siloed fields, or maybe in very specific fields. So the bridge between all of these types of things is the official deployment and monitoring processes and timelines for machine learning models. Make the process of deployment of a machine learning model operational and extremely trusted, right? So if you get it to a point where the process is sequential, there's a release, there's a deployment, there's a development phase and a deployment, there's a monitoring period. There's trusted guards to make sure that the model is performing the way it should in the operational capacity that it's working in. Then you will start to build trust in it in a way that you would then use automated sources to call the model as well. and build them. And if we build them in as many different use cases as we can, we'll start to see it become much, much more prevalent as a bridge for the AI technology as well. So that's what I think of as a very solid approach to getting towards operational use cases. So one additional use case I want to provide is just an example we had at a previous company, again at Palantir, which with this use case called Skywise and airline ops. And what this will, I want, all of the types of problems we can start solving. If I've already mentioned this, if we get the data model correct, and this will really demonstrate the types of things that are available to us, the types of decision-making tools that are available to us once we get the data model vetted and in use. So for those who don't know, Airbus makes airplanes around the world, probably the biggest competitor to Boeing, one of the biggest companies in the world, if not the first, second biggest. And Skywise is a Palantir project with Airbus, and it represents Airbus's data model distributed across thousands of use cases and different airlines around the world. So basically, imagine hundreds of airlines pooling all of their data together. Security across all of those are maintained, right? So each airline has access to its data that it's provided in. All of that's connected into the Skywise data that Airbus can see, right? All of the aircraft they're creating, data is feeding into this data model from Airbus, and then they're giving back some information to all of the airlines, predictive information, knowledge across all of them that's maintained, the security is maintained, and is useful across different use cases from the perspective of the manufacturer to the different airlines themselves. The goal is massive. It's to improve all airline operations and all airline safety using critical aircraft data. And what the image shows you here is that the value that the platform seeks to create, this is the Skywise platform, which is really just a Palantir workspace. The value that the platform seeks to create is unique for key stakeholders in the aircraft ecosystem, right? So everyone has a different use for the data lake, for the data model, for the analytics that's being produced on top of it. And there's a ton of different entities that are represented. And if you think of users as being connected to an entity, then you could think of them as having use cases pertaining to that entity. So you have technicians on aircraft, technicians on pieces. You have executives on flights or on groups of flights or on periods of the year. You have passengers. You have use cases related to passengers. Maybe that's an entity that is worth identifying, right? So all of these things, once they're clearly vetted and put into a capacity that makes sense for real world, then non-business owners start to ask real business, non-technical users start to ask real business questions about the thing that they can interact with. And if you have the tool to then help them engage with in meaningful ways, both on a data level and on an analytical level, then they'll start to ask these more operational use cases and make those decisions inside of the platform. And so the platform then becomes the place in which operations occur, which then opens the door to machine learning models being built within each of these different venues. For example, predictive maintenance. When should I predict maintenance will happen or maintenance will be needed? Therefore, I can preemptively put the aircraft out of service and perform the maintenance on it. You have tons and tons of different use cases. When will I predict that a customer will cancel a flight? And what can I do with that information? And so once you have decision makers, operators asking these questions, you make your workspace a place where machine learning models can play a critical role in helping out. And once you have that in place, only then will you be able to sort of on top of that build a language model that incorporates both the data ontology, the machine learning models, and the operators, the business owners themselves into the process to contribute to this massive undertaking, which is to make these AI bots, this technology, become operational in use. And so that's sort of the goal. And having this type of ecosystem, once you get the AI model, once you get the data model correct, and you start bringing machine learning models into the system, you really open the door to the next generation of AI technology in an operational sense. And so that's where we should be aiming. But again, most people have not done this right yet. It's still a really, really open question. So I just want to speak briefly at the very end, last couple slides. I want to speak briefly about tact and technique. How do you get people to start using these technologies in an operational sense? How do you start rolling out operational use cases without upsetting a few people? And so just four small notes. So the first one, use case sourcing. You want to keep buy-in from a lot of different people, right? So if we focus on operational AI, how do we make sure that operators, the ones who are actually making those decisions, don't feel like their jobs are at risk of being replaced and get the best possible outcomes? If you want to make sure that the businesses are protecting, businesses are going to protect their employees and going to protect their processes. And so you need to frame things in ways that don't threaten jobs. Instead, we want to keep the buy-in at all levels and have the people at the operational level have their own buy-in for bringing new technology into their job to make their job better, easier, so they can do more complex tasks. On the data pipeline side, how do we simplify the data model through transforms? So having better, how do we have better hygiene and foresight? How do we embed the data model with business logic instead of having different tables for different things? Put everything in the right place. How do we simplify the data model as a result of better thinking beforehand? Two other thoughts on the management side. Sometimes you have use cases that are that are started but end up being dead ends, or they just don't have enough value, right? The part of it that's not optimized is too small, and there's no automation that would be worthwhile at this point to set in place, right? You spend all this time investing. So remembering that if the objective of the data team is business, then you don't have to entrench yourself into one use case. You can easily pivot once you realize that it's not worth it for the business. There's no reason to be defensive about that kind of thing. So how much time do we invest in a use case, a deep dive, and the ontology that we're building before deciding it's just not worth it, right? It's not worth the time to build the ontology because it's not going to provide real business value. And if we can be use case agnostic and just get the results wherever you can find the results, that's going to be really valuable when thinking about pushing these things forward. And then finally, stakeholder trust, right? How do we decrease the risk of bad decisions from models? So if we want to do machine learning models very well, and we want that to be the bridge where operational AI becomes realistic on top of the data model, well, we need to de-risk the bad decisions that could happen. So maybe that's human-in-the-loop processes. Maybe that's other types of processes that would ensure that the executives and managers in the business feel confident that decisions are being made appropriately and the models are well vetted. Like I mentioned previously with machine learning deployment processes, those types of things are critical for rolling out these use cases. Okay, so I'll pause there. Just want to say, overall, this is a really, really meaty topic. There's tons and tons here. The space is very, very rich with development, and it needs to be even more rich with development. And we need to focus on operations to make this thing useful and not just a massive bubble of ChatGPT, wrappers that fail as businesses. We need to make them real businesses that focus on real businesses, that focus on real outcomes. And hopefully we'll get there soon. So anyway, thank you very much for all who are here and listened, and open up for QA.
Oh, just wow, I should say. Thank you, Josh. That was a really stirring, informative, and thought-provoking session. I am sure our audiences learned a lot from you. It's truly inspiring, and we are so thankful for your contribution. Heading towards the Q&A session, please keep your questions coming in the Q&A window. I guess we have some questions for you from our captivated audience. And the first one coming up is, Josh, you draw a lot on your experience at Palantir when talking about the process for getting to realistic AI outcomes. What type of company culture should companies aim for if they want AI technologies to be a success for their employees?
Amazing question. I actually had a slide on culture, but I dropped it because my wife said it was too long. So culture is extremely important. And the cultural decision comes with dropping the boundaries between teams and comes with business outcomes. So if everyone in the company is focused on outcomes, business outcomes, then there's no reason why the business shouldn't be able to succeed in releasing some of these technologies. Everyone's looking at it from an outcome perspective and not from a perspective of investment or tools that they built.
Absolutely. The second one is, when we talk about AI, many have brought up ethical or moral concerns about the accuracy of statements and presence of bias in the models themselves. However, when we bring real-world operations into the mix, for example, financial lending or career choice recommendations, we heighten the level of risk significantly. What in the process for development and rollout of new technologies is meant to counter that? Is it inevitable?
Good question. It is probably inevitable to get some things wrong in technology, but the process is important. So the first of all, I mentioned earlier as well, human in the loop is really important. So is a rigorous vetting process for any legal requirements. So, for example, with lending, if the model needs to be extremely sure that it doesn't take into account things that are illegal to take into account, but that doesn't account for bias of things through like other proxies. So even if you don't include gender inside of a model for predicting who to lend to, you still might include something that's a proxy for gender. And so yeah, it's basically like, you need data teams who are rigorously asking those questions, right? So it's part of the culture question, and it's part of the business question. It's that the deployment process needs to take into account the actual objective, right? It's not just we want to release a model that is that is valuable from the business perspective to get more money. We also need to make sure that it's long-term and maintainable. And that's part of the deployment process. But I'll be honest, I've never seen something that's been perfect on deployment, and having that as an expectation, it's good as long as there's rigorous vetting processes, even post-deployment.
Sounds really great. I have another one coming up for you. What operational activities are most likely to be impacted first by AI, artificial intelligence?
Yeah, good question. So it sounds like the question is kind of similar to a question about you might have asked 10 years earlier, which world problems would be most impacted by machine learning? And those types of problems were things like recommendation problems, predictive problems, right? So, whether it's advertisements or lending or like insurance, or even, weather risk, those types of problems are probably the most likely to be touched on first. But in a way, the way I think about it, it's actually a question for each business. Which businesses would have the easiest road to getting to operational use cases? And again, that's probably things that are completely digital as opposed to things that are completely that are in the real world. But I can tell you there are some real world use cases I know of with physical objects that have already started to roll things out. Like aircraft is a good one. Which aircraft should I swap for? If it's going out for maintenance, automatically swapping it for a new one. Understanding what the maintenance operations, how that impacts revenue and how that impacts customers, getting their flights canceled. All of these types of things are actually being rolled out. And so in a way, it's kind of like the first mover advantage. Which companies have been thinking about it first will probably be the first to roll out, and not simply the question of what types of industries will be most likely.
Really, that's such an insightful thing I've come to know. One we have from our audience again, how can we get buy-in of our ops people? Resistance is huge and they see us as enemies, so that they are not even sharing any business logic so that we can be successful. They feel threatened because of the bad media, in my opinion. So
Yeah.
what is your say? I mean,
yeah. Well, sometimes it means you don't have buy-in at the top. You might go too low. You might go too far to the operator, and you actually do need buy-in from a more executive level. But sometimes it's just about the framing, right? If you come across as someone who wants to replace someone's job, or someone who's going to move resources from one part of the organization to another part of the organization, you might be going about it the wrong way. But I have never seen a situation where this has been done perfectly, right? There's always pushback from people who don't want change in the organization and want to keep operations the way they've always done operations, and that's never going to change. But what it means is that you almost always need one key stakeholder at every level, right? So if you want to push out a new use case, you need a stakeholder on the operational level, someone who understands that, okay, my job is really hard. I'm maybe often a little younger in the business. They recognize that they're new to a team, and they want to be a champion and see themselves grow in the business. So you can find that type of person, and they'll help you kind of ride the wave of technology embedding into that team. And then you need to find a manager level who has appreciation for how the technology can positively impact the organization. And then as well as a manager level, you also need executive level typically to get coverage, right? So when a use case is taking months to roll out, you're doing a new thing, right? It's taking some time to get the data model and taking some time to get the use case and in reality rolled out. You need some coverage to set timelines in the organization to make sure that that even if you on the first week or the second week you don't find a specific answer that everyone's looking for, you'll have something moving forward. But your goal should be get as quickly as you can to solving at least one person's job, making one person's job easier. And once you can do that, probably on a younger person in someone's team, you're much more likely to get buy-in from managers and then executives along the way.
Wow, that's so rightly said. Actually, we're running out of time, so I would conclude with just last question, I would say. Will we ever get rid of the double trust problem as you described it, a lack of trust in the data model and in the decision-making process? Should we go ahead with this?
It's a good question. I would say we should minimize, but we should also understand that as companies grow, the data model will grow. So the ontology of an organization will always grow, and you should always have a data team or people pushing towards improving that. But it's likely to not completely go away. On the model side, it's very similar, right? So new use cases come up. At least in the near term, it's very unlikely that we would be able to get rid of the problem of trust and decision making. But it could be that on some problems we sort of solve them one at a time. So this problem becomes easier, and then this problem becomes harder, et cetera, et cetera. We sort of move through the chain of operations sequentially. But it's a really good question. I don't expect in the near term for this problem to disappear, but we should mitigate it one step at a time.
Completely agree with you, Josh. Completely agree with you. Thanks a lot, Josh, for that insightful session. It's time to wrap up for this session. We appreciate you all being here. Please go back to the agenda and join us for the next training session on Data Zen. Do take good care of yourself. Thank you.
Thank you, everyone.
Bye.